Hi and welcome to MSc. In this video we're going to be looking at balancing chemical reactions. So chemical reactions must be balanced so that the same number of each type of atom appears on both sides of the chemical equation. For example, down here I see a silver atom, Ag, and over here I see two of them. So this would imply that we've somehow created a silver atom. Here I see that I have two sodium atoms, and here I only have one. This would imply that we have somehow lost a sodium atom. This is a chemical reaction here, not a nuclear reaction, so we're not actually changing the nuclei of these atoms. So just like a recipe that might have more than one ingredient leading to one product or a dozen products if you're baking cookies or something like that, we have the same setup here where we need to fill in the rest of the recipe. How many of these silver iodide particles do I need to combine with the sodium sulfide to produce the silver sulfide and the sodium iodide? To do this, we put coefficients in front of the species in the reaction. So we'll add whole number coefficients in front of these species. We can never, when balancing, do anything with subscripts and change them in any way. It will only be adding coefficients. So let me take you through my method of how I balance chemical reactions. I start by making a chart, and this separates the reactant side from the product side. And then I list the elements, and I usually just list them in the order they appear in the reaction just so I don't miss anything. So here I have silver, I have iodide, I have sodium, and I have sulfur. And then I list how many I have of each. So here I have one silver, one iodide because their subscripts are 1. Here I have 2 of the sodium, and I just have 1 of the sulfur. And then I repeat the process on the other side. And I always try to make sure I keep them lined up so that they're the same, even if this is not the order that they appear in on the product side. I just keep it the same as the reactant side. And then I go and update my chart. Here I have 2 silver atoms, I have 1 iodide atom, 1 sodium, and 1 sulfur. And now we can clearly see which ones are fine at this stage and which ones are not. So, law of conservation of mass says that I need to do something here to have 2 silver atoms on this side. Now, as I mentioned at the beginning, I cannot just add a 2 there. I can never, under any circumstances, change the subscripts. But what I can do is I can put a coefficient in front. So I want to put a number here that when I multiply it by 1 will give me the 2 that I want from the other side. So in this case, it's a 2. 2 times 1 is 2. And so I update my chart. Silver is now balanced. And now I also have to look at the iodine. And I'll see here, oh, it was balanced. Now it no longer is. I typically just work down the chart. There's some tips and tricks you'll find if you've been over this for a while and are getting a little bit better at it. One tip I'd say is if you see one element that's in more compounds than the others, save it for the last. Here we'll see each element here is in 2 different compounds, so it's not a big deal. But in some of the bigger or more challenging ones, you might see oxygen, for example, show up in like 3 of the 4 compounds, in which case you definitely want to save it for the last, even if it's not last in your chart. In this case, I can just keep working downwards. So I have 2 iodine here. I need to have 2 on this side. And I'm not going to despair that I've unbalanced the iodide by balancing the silver. It's a process that we have to work through. I have 1 iodide, so I want to put a number here that's going to multiply to give me the 2 that I want. So I'm going to put a 2 here again, because 2 times 1 is 2. Notice that also changed my sodium value. So I'll update my sodium. And as it turns out, it's balanced now. Right? By updating the iodine here, I've also fixed my sodium problem. The nice thing about these balancing questions is that you can always check your answer as well. And I suggest doing this at the end of the test, going back and looking at them. Or if you need to use this in the next part of a problem, for example, which can happen in some other chemistry classes, is take a moment, not looking at your chart, and just actually count them out. I have 2 silver, I have 2 silver. I have 2 iodine, I have 2 iodine. 2 sodium, 1 sulfur, 1 sulfur. This appears to be balanced. And being able to check your answer is great because it gives you confidence that you have the right solution. I like crossing out my values as I go through because it allows me to kind of track what I did if I run into problems. And as a teacher, if I'm trying to mark through and follow what a student did, it allows me to track their progress and be able to help give them feedback on where they went wrong. So here's another example I'd like to try. It has a little bit of some different nuances from the one we saw before. Again, I'll set up my chart. We see that we have phosphorus pentachloride here. So we'll list this out, phosphorus and chlorine. And we have it reacting with water, H and O. And then I'll fill in the number I have, 1, 5, 2, 1. Right, 1, 5, 2, 1. And then I'll keep the same order on the other side, even though this is not the order they show up in on the product side. So phosphorus, I have 1 as part of this phosphate ion that's been formed. This is phosphoric acid. I have chlorine here, there's 1. Hydrogen's tricky because I have 1 here and 3 here. So that's 4. And the oxygen is also 4 from the phosphate. So be careful when you see it in multiple places. And this is an example of where I would probably save hydrogen for the end because there's 4 compounds. It's in 3 of them. So even though in my chart I've listed it as the third item, I think I might save it for the end unless when I get to that point things are already balanced or I'm one move away from being able to balance it. So start at the top here, phosphorus, 1 and 1 is great. The chlorine, I have 5 here. I need to put a number out front. So 5 here times 1 gives me the 5 that I want. It also changes my hydrogen value. And it's really a common mistake to be like, oh, times by 5, I must have 20 now, which is not the case. I have 5 times 1, which is 5, plus an additional 3. So this becomes 8. Okay. So now I have a choice. I can try to figure out what to do with my hydrogens here, or I can jump straight to my oxygens. I think in this case it probably will work out either way. Let's skip the hydrogens and go to the oxygen. And let's see, okay, well, what would I put here? Well, clearly I'd put a 4. 4 times 1 is 4. And that will also change my hydrogen. So in this case, it wouldn't have mattered if I tried to do my hydrogen first or my oxygen. It would have been fine. But again, general rule of thumb, leave that element that's in lots of things for the last stage. Let's do a quick check of this. 1 phosphorus, 1 phosphorus. 5 chlorine, 1 times 5 chlorine. Okay, hydrogen is 8. 3 plus another 5 is 8. And then 4 oxygen and 4 oxygens here. Okay, notice in this case I treated the polyatomic, this phosphate polyatomic anion, as separate entities because it's being formed. I don't see it on both sides. In a later video I'll do an example with a polyatomic where we see it on both sides and we have the option to treat it a little differently if we'd like. I hope this quick run through and some examples of balancing chemical reactions has been helpful. If it has, please consider liking this video and subscribing to the station. And as always, thank you so much for listening and watching.